Now, this video is aimed to talk about the theory for chapter 7, which is file management. Okay, so after chapter 6, which is about the device management, you have the input output, and then what are the way you can access to a file, what are the time taken, buffers. We talk a lot about what are the ways, and actually what are device controllers, device drivers, so on and so forth. Now, in your last chapter, that's kind of going to come out in your final exam, which is chapter 7 about file management. Still the same. You have learned this in chapter 1. We have file manager. So file manager have its own functionalities and also responsibility. Like the file manager need to make sure like how the system are organized, because this will affect on the efficiency. And then how are they stored? How each file record is being structured, and how do we access the file? Okay, so in this chapter, okay, the responsibility of file manager, what does the file manager do? I won't talk about, you can study on your own. And some important definition like what is a field, what is a record, what is a file, what is database, what is program files. You also can go through it on your own. Okay, let me explain to you. Oh yeah, interactive with the file manager, this one also we didn't go much into that. Now I'll go dive in a little bit about this file organization. Okay, when we talk about file organization, it's actually we talk about how different records are being arranged and the characteristics of which platform you use to store it, which basically which medium you use to store it. Okay, now file organization, there is three file organization. Basically, there are three ways that we can arrange or store the records. Yeah, basically it's more like arrange. Okay. Now, first of all, sequential. If you have watched the chapter 6 video, sequential basically is serially one record after another. Okay, I've talked this before. Sequential, one by one, one by one, one by one. So the way is what we call sequential. If you have direct, okay, direct, it's similar to chapter 6, the logic as well. Now, if you have a direct access, basically you directly grab the data record. So that's what we call direct. Now, you have last one, which is index sequential. Okay, you have not learned anything about index sequential before. So don't worry. Right now, just remember, keep it in your mind that we have these three file organization method: sequential, direct, index sequential. Of course, I'll go through into this each of them later. Now, in order to consider which type of file organization you should choose, right, you have to consider four things. First of all, you consider about volatility of the data. Okay, volatility of the data is try to say like how frequent or how long in time period, right, you are going to make changes to your data. Is it, are you going to change your data every single second? Or are you going to change your data half a year or quarter in a quarter? So that's what the volatility of the data. Now, the second characteristic to consider when choosing which file organization to use is the activity of the file. So you have this file, a lot of records, right? How much records do you actually use it when you try to run something? So that's the activity of the file. Then last two, for size of the file and the response time. The response time is talking about, now size of a file basically how big or how small. I think you guys get the idea. The last one, which is response time. Response time is saying that how much time that a user is willing to wait. Basically, it's like, okay, if I try to deal with this file, right, maybe I want a reaction in 1 millisecond. That's pretty fast, right? So that's the response time lah. Okay. So if we were to put into words, it's the amount of time where a user is willing to wait before the request operation is completed. So remember, there are four characteristics that you need to consider when choosing which file organization to use. And also, when we talk about you can choose file organization to use, right, you have three types, which are sequential, direct, and index sequential. Okay, with that being said, we go to the first one, which is sequential record organization. Now, look at this sequential, which means serially, one after another. I have repeated so many times. Serially, one after another. So the good thing about sequential is the easiest to implement. It is not complicated, directly straightforward. Okay, after this record, okay, down the next record, okay, attach to the back. That's it. Okay. Now, in order to search for the file, you have to go from the beginning until the record that you wish to find. Okay, and of course, we need some optimization features. When we talk about optimization features, it's like, I know I need to search this thing from beginning until the record file. Now, can I speed it up a bit? Okay, so that's what when we talk about optimization. So you can do it. Okay, it's like you select key from the record and to sort. Okay, now one thing is that sequential, because it is so easy to implement and serially one after another, normally we will just apply it in batch applications for your information. So that sums up the first type of file organization, which is sequential. The second one, direct or random. Okay, direct or random record organization. So when you talk about direct or random organization, the easiest way to remember this thing is, if you ever handle databases before, database. Now let's say I have a table student record. So I want to get this student record, which name is Winnie. Okay, I'm trying to get a record for myself. So I'm gonna do the query. Okay, I'm gonna query say that select all from TBL student where student name equals to Winnie. So it will only return, let's say the whole school only got one Winnie. It will just return the record of me, right? Winnie. So that's when we say it is direct enough, random enough. You can access to any random data as long as the data is the thing that you want. Okay, direct enough. So this is what we talk about direct. Okay, before I go into the next one and also detail, one thing you need to know, why do we have index sequential? Okay, why do we have index sequential? Is because when we're using direct record organization, there's actually a big disadvantage. Okay, there's a big disadvantage of error, which is called collision. Okay, now what is collision exactly? Okay, the advantage here, you can go it on your own. Let me talk about collision. Now, what is collision exactly and why it will happen in direct access? Okay, it's because when we are trying to do direct access file organization, you actually will pass in a key. Okay, like for example, this key 123013. You pass in the key to the system, you will go through a hash function. Like example for this one, in order to get the address, you need to use the pass in key mod with 307, then you add with 1. Okay, after you pass in your key to go into this hash function and do this expression or do this equation, you will get a value. The value which is 214 in this case. The value that you get is going to be the address. Okay, the address where your record is being stored. So in this case, I repeat again the idea or the logic. How do the direct access organization actually works? You have a key, you pass in the key to the system is going to run a hash function, or what we learn in our high school, which is equation. The key is going to go into an equation and execute, then you get a number. The number that you get is going to be the address, okay? The address that your record is being stored, logical address. Okay, now, until this point, I haven't talked about collision yet. Okay, continue on. Let us talk about collision. When you look at a key being generate or being go through a function to become an address, it is still normal until when you have two different key. The first key is 123013. The second key is 151564, right? Obviously, pretty obvious. These two key are different key, correct? So by right, different key are actually different records. Now, different records by right should store in different logical address as well, right? But in this case, two different key, I go through the hash function, which is this key mod 307 plus 1. I get the same address, which is 214. So what happened? You have two different records with two different key actually generate the same address. So they collide with one another. So this is the big problem where we call collision. Okay, big problem where we call collision. Now, if you still don't understand collision, look at this definition. You have more than one records, okay, with different key, unique key, basically different key. where they generate the same logical address. So that is what we call collision. So what happened? You see, when you have two different records that actually put under the same address, so you look at address 214, by right you can only store one value, one record, which is for this Dudley. But then this 151564, which is Rich White, also 214, point to 214. Hence, it will become collision problem and the record will be stored in the overflow area. So in this case, if it really happened in real life, right, programmer have to go and reorganize and rewrite the file. Okay, I think here got mentioned. Here lor. Okay. So this is the colliding records that actually store in the overflow area. This is the issue where we call collision. So collision only happen in which access? Direct record organization. Now the last part, index sequential. Okay, when you talk about index sequential, basically it is a combination of sequential and direct access. So you combine both of them together. Okay, why do we actually use or combine the sequential and direct access? Because we want to solve the issue of collision from from the direct record organization. So previously, you look at that the direct record organization will cause you collisions, right? Now, when we talk about index sequential, our first aim is actually we want to solve the issue of the collision. So in this case, index sequential doesn't create a collision because it don't use the result of a hashing algorithm. So instead of using the hashing algorithm, go through a functions or equations, right? In index sequential, you are not going to go through any equation. Instead, how do you gonna work? You are going to have one index file. Okay, you have one index file here. This index file is going to store the key and the address respectively. So you don't do hashing here anymore. You just store the key and the respective address. Okay, now you won't store two keys with the same address anymore because you don't have hashing, right? So like for example, if you store everything in this index file already, I have one key 166702. I look over into this index file, 166702 key is going to have an address of 003. So by mapping, I know that, oh, this record for this key is actually 003. I go to my logical address, I go to 003, I found the record which is Harry Eagle with the balance. So this is what we call index file. It's like mapping already. Okay, let's say I have another key which is 121267. So I point over here, 121267, address is 002. So I go to 002, it's actually Brian's record. So it doesn't have the collision anymore. So this is what happened when you try to use index sequential record organization. It can solve the issue of collision by using an additional index file to store the key and also the respective address. Okay, now with that being said, right, now this is being done where we have going through the three types of file organization. Okay, let me repeat. We have actually done with the file organization, which are sequential, direct, and index sequential. Okay, now we go to the second part. Now the second part is the actual storage allocation, which means the physical storage allocation. Okay, so when we talk about the file storage, okay, we're talking about like how do we actually store this file. The file requires storage, right? If you don't have storage, how do you save your file? So when we talk about physical storage allocation, there's a few styles where we can actually store it. The first one, which is the easiest one as well, contiguous allocation. Okay, when we talk about contiguous allocation, it's better for me to use this diagram to show to you what does it mean by contiguous. Contiguous means continue, right? One after another, right? So in this case, let's say you're applying contiguous method. You have file A. The start block is 2, length of 3. In that case, in your storage, file A, block started at 2, 1, 2, 3, length of 3. So 1, 2, 3. So you can see it is contiguous. After 2 already, you don't space, you continue 2, 3, 4. So the length of 3 belongs to file A. So you see it specifies file A. So come back here, contiguous allocation, basically your record store one after another. Okay, one after another. So there are pros and cons as well. If you're talking about the good part is that you are easy to access once you identify where the file is. Okay, but if let's say suddenly you want to expand, okay, for example here, the file C, is it file C? Yeah, file C start at 18, end at 25. Example, you want to expand file C, so it's like after 25 the record already, you want to add something into your file C, so you have expansion, right? But then 26 is occupied with file E already, then in this case it will be much harder to handle. Okay, and of course in between, like you see this one, 0 and 1 the block is empty, 5 6 7 8 is also empty, so you're actually wasting the memory storage. Did you see this? That's why when it have fragmentation, what we do is we can compact and rearrange. So we can do compaction. So what does it mean by compaction? It's like you rearrange the file already, okay? Then you compact all the remaining empty blocks together. So you see the compact, after you compact already, they are down here. Then the fragmentation is being reduced. You can put other file, continue, maybe you want to start from 31 and then you keep on going. So this is what happened when we are trying to use contiguous allocation. Okay, the second one. Just now when we talk about contiguous, it's like one after another. It must. The second type, link allocation, works differently. Okay, how different it is? Your record don't have to be one after another. As you can see, file 1 is here, file 1 is also here. After file 1 already become file 2. Now you see, block 2, you got file 1. Block 8, you got file 1 as well. Block 20, you got file 1 as well. Block 18, you got file 1 as well. So when you can like store it in different block, right? So in that case, this is called link. Okay, why do we call this link? Not because it is like storing everywhere. We call it link because look at here, file 1, I start at 2, end at 18, I extend for 3 times already. We call it link because file 1 start at 2, file 1 start at 2. So this 2 is file 1. It is being linked to block 8. So when I go to the link of block 8, it is also file 1. Now file 1 is being linked to block 20. So we go to 20, 20 is also file 1. And you look at here, file 1, okay, and this block 20 is linked to the block 18. So you go to block 18 also file 1. So you see how many times it extend. Extend for 1 time, extend for 2 times, extend for 3 times. So this is the number of extend, which is 3 times. So this is link allocation. You are allowed to use any storage available. You don't have to say one after another, one by one. No need. As long as there is available space, you can store it. Okay, how to store it? You actually link together with a pointers. Okay, so this is what happened in link. Now I move on to the third type. Okay, first you have contiguous. Second, you have link. Third, you have index allocation. Now, instead of reading all these notes, right, you can go by yourself. But let me tell you when we use index. Okay, I'm gonna zoom out a little bit. So when we use index, right, it is pretty simple. Now you're gonna have this index table. Index table, you will list down which file having which index block. Like for example, this is file 1. File 1 is having index block of 12. So when you go to 12, okay, block 12, 2, 8, 20, 18. It actually store all the index. Okay, all the index that you can actually refer to. Basically, this block 12 tell you that block 2, block 8, block 20, and block 18, they are also belongs to file 1. So when you look at this block 2, file 1. What about block 8? Block 8 is also file 1. When you look at block 20, block 20 is file 1. Block 18 is also file 1. So do you see the difference? Now it's different from link. Link, you have pointer to link them together. Index allocation, you dump all the block number into one single index block. So this is called index. Okay, if you can understand under this part, you are almost there. Okay, you're almost there. We're going to go for the last part, which is free space management. Now, what is free space management? If you recall, you look at here. Okay, you look at here. Do you see like, okay, over here. Did you see? You have actually empty record, right? Empty free space, free space. So when the storage or when the memory, it is not being used, we call it as free space. I repeat, when the memory or the storage is not being used, you call it as free space. So that's why over here 7.5, we are talking about how we actually manage or handle the free space, which means the memory that are not being used lah. Okay, so the first one, which is the easiest one, which we call bit vector. So bit vector, right? You actually put them into 0, 0, and 1, 1, 1. So if it is occupied, you put 0. If it is not occupied, you put 1. I repeat, if it is occupied, you put 0, which means if it is in use, you put 0. If it is free, or which means if it is not occupied, not being used, you put as 1. Okay, so when you do about bit, okay, bit listing, okay, you're gonna put in 0, 0, 0, 1, 1, 1, okay, and so on and so forth. Okay, but of course, bit vector is a way that you might require some calculations. Okay, require some calculations. For example, I tell you that the block size is 2 to the power of 12 bytes, and the whole disk size is 2 to the power of 30 bytes, which is 1 gigabytes. Okay, so in order to calculate the blocks, right? Okay, how many value per blocks? So you have to use the bigger value to divide with the smaller value. Basically, is you use the whole disk size to divide by the block size. Then you get how many blocks. So for in this case, we actually get 18 blocks. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 2 to the power of 18. Okay, yeah. So in this part, I'm not sure whether the final will come out of these small calculations, but I think it's better for you to understand what is happening here. All right. Now, after we use bit vector, we have another 3 type, which are linked list, grouping, and counting. So all this text thing, I won't go into it. You can read it on your own if you want. I will just tell you what are them doing. Now, if you are doing linked list, you're going to start with like that, like this. Free space list head, which means you're gonna start with the available one. So this one is occupied, occupied. This one is available, available. So you are doing linked list, right? What you're gonna do is you're gonna draw a line, you link them together. So you link from here to here to here to here. Basically, you link all the available, like the blocks that are empty. You link all together until the end. So that is called linked list. Pretty simple, right? Okay, so this is the link. Now, the next one, which is called grouping. What does grouping mean? You're going to store the free blocks into the first free block. Now, for example, you're going to store n number of n, which is 3. So what happened is that in block 2, you're going to store the blocks that are available or free after 2. So in 2, you're going to store 3, 4, 5. In 5, you are going to store 8, 9, 10. In 10, you are going to store 11, 12, 13. In 13, you are going to store 17, 18, 25. Okay, and in block 25, you're going to store 36 and 27. That's it. So this is grouping. Now, normally, we'll just learn about grouping with a number, default number of 3. So it's a block 2, you're going to store 3 blocks behind 3, 4, 5. Block 5, another 3 blocks behind 8, 9, 10. So that's about grouping. Okay, now we go with the last one. Okay, the last one is the easiest one. It's like you start from the first free block and then you calculate the number of free contiguous blocks that actually follow. So what does it mean? It's like, for example, I start with block 2. Okay, continuous free space behind block 2. Okay, start from here is 1, 2, 3, 4. So you get 2, 4. Okay, if you don't understand, you look at here again. When you do counting, you look at the contiguous one. You cannot say, hey, why not 2, 3, 4, 5 already? Then I got 8, 9, 10, 11 also, right? Look at here, 6, 7 is occupied. The continuous free space is just 2, 3, 4, 5. So if you are trying to do counting, you start from 2. Okay, this is block 2, right? Start at 2. Okay, how many free space are continuous? 1, 2, 3, 4. So here you get 2, 4. Okay, continue on here. You start from 8, right? 8, okay, 8 available. So we start from 8. Okay, count 8 as 1. 1, 2, 3, 4, 5, 6. So you get start from 8. Continuous available space of counting is 6. Then the next one, which is 17. So start with 17, you count 1, 2. Only 2 blocks that are continuous together. So you count at 2, 17, 2. And the last part, you start at 25, right? So start 25, 1, 2, 3. So which means you start at 25, having a counting of 3 contiguous blocks altogether. And with that being said, that sums up for the last chapter, chapter 7, that's gonna come out in your final exam. And that's it.